Hello and welcome to this mini-series about Java Reflection API. Last time we covered annotation processing and saw how we can give user a possibility to configure things on their own classes using our annotations to enable some of the functionalities. Till now we focused on reading things using Reflection API, but we are also interested in invoking methods. For example, allowing to execute users' custom code inside our framework without knowing any implementation details. Or plugin system where user can implement our interface, add it to our class path, and we dynamically load it up. As for today, let's focus on invoking a function of an unknown object that we have received. So last time we implemented two annotations. One was JSON ignore that we could apply on a field and it would be ignored from the expected output that we generate. The second one was JSON property, which allowed us to rename a field before we are outputting it into the JSON. So before jumping into our implementation and trying to add directly the code, let's quickly look how the method invocation actually works from reflection perspective. So let's define a class, for example, book, that has some method public void print title. And here we just will output title. So when we assign an instance to an object type variable, we have lost all the information about that it was book. We can again get the class back. Let's see what methods does the class hold. And let's go over one by one. So method in methods and print some information out. For example, let's have it in the signature order, get return type, then get name. And we would be interested maybe in parameters, get parameters. So there is a list of parameters, or we can just get the parameter count or parameter types. Let's take parameter types. As this is array, I will wrap it into this toString to have some good output. And let's run this function. And we can see we have found out that there is one single method, void print title, that is accepting no parameters. So here if we would like to add a string name, for example, as a parameter and we would execute it, it would appear here. So now we are interested in invoking this code. So this is some custom code that is added to our class path and we would like to dynamically run it without knowing what it is. I know that there is only one method. I will now remove the for loop and just extract the first method. And I would like to invoke it. So method, and there is a function called invoke. We can invoke it on this object. It can throw, of course, an exception. I will just add to method signature and now run it. Running now, it will fail with error because it is accepting an argument because I have added here the name. If I remove this name, I can successfully run this function. And we can see we have executed users defined code without knowing what's inside there. Same goes with parameters. So if we would like to add here this title back and output it together, in the invocation we should provide a list of parameters and then we can again rerun this function. And now you can see how easy it is to invoke user-defined function using reflection. So till now we have allowed the user to ignore something, rename something, but we also know that we would like to perform some transformations. For example, if we have a field first name and last name, maybe instead of outputting two fields, we want to concatenate the result into a single field. Or user would like to change data formatting or make all letters capital. There are unlimited possibilities what user would like to do. So we need to somehow enable some custom code that they could execute to perform the transformation. For this purpose, getter function would be the best match. User could define it on its class, mark it, for example, with JSON property, give it a name, and we would understand that the output of this function should be included in the JSON as a field. By this, we have all the necessary logic on the user side, and we only do the annotation processing. Now, let's again start with a test to define our expected behavior that we are sure that we know what we want to implement. So we need some structure, for example, book that will have author name and author last name. And what we really want to do is to actually not output these fields, but have in output one single concatenated value like author. So for that purposes, I would like to mark author name as JSON ignored and author last name also as JSON ignored. We know that these fields will be excluded from our output and we have covered it with the tests above. Now let's replace those fields with a getter that will concatenate the results together and output as a single field. Let's define a getter get author that would take author name and concatenate it with author last name. For now, it is by default excluded, but we actually would like to mark it with JSON property and add a name, for example, author. It's red, and that's because JSON property is not applicable on method. Last time we discussed that annotations can be limited on scope where they can be applied. For example, on a field, on a class, or on different annotation. This JSON property was applicable only for field. Right now we want to extend it and allow it to be both on field when renaming and on method when we are trying to use this getter approach. So here, instead of target element type field, we want to expand this and we can provide a list of values here. So let's add one more, element type method. Now this annotation can be applied both on fields and methods. If we go back, we can see the error is gone and everything is okay. Nice. Now let's define our input. New book, John Doe. In when section we want to perform our action and collect the results. Mapper to JSON and provide our input. And then we define our expected value. In this case, there will be only one field that we expect. It should be author and its value should be John space Doe. And then we do the assertions. Expected and actual. Let's run it. And indeed, we see that the test has been failed and the expected is what we have defined, looks correct, and the actual is empty curly brackets because we have marked these fields as JSON ignore. Looks correct. So we have defined our requirement as a test. Now time to implement it. Now we need to expand our toJSON function to include also declared methods. So simplest way would be add here methods and as class for them, declared methods. But we know that we don't want to collect actually all the methods. We are only interested in methods that are marked with JSON property. And I would add one more criteria that it's a getter, meaning it has a return type and has no arguments. So function should just return value, like a supplier. It should only provide a value that we can consume. Because we as a framework or library owners, we are not sure what is the input needed for that function to succeed. Let's go down and create a method that will return a list of methods. Get methods from given object. So let's start by finding again the class of the object. By object get class. Then we can query for methods. Using this class get declared methods. Let's create a stream from these methods and we would like to filter out the methods that we are interested in. So for example, the first thing that we know that the method should have our annotation. Present JSON property. By this, we remove all the methods that are not marked by annotation. And as mentioned, we only would like to focus on getters, because otherwise we do not know how to invoke that method. Let's create a helper function that will test if this method is a getter or not. Is getter. We will provide a method. So method get return type. We can see it returns a class, and we want to be sure that it is not equal to void. If it's not a void class, it means there is something this function is returning. And we want to be sure that there are no parameters required. So method get parameters. So we can just see if parameter count is equal to 0. Let's add that to our filter. So next step, we want to filter only methods that are getters. And we can replace that with lambda reference. We can collect them to list and return back from this function. This line can be replaced with get methods and provide object. In this case, this is an array, this is a list. Technically, it would be really great if we at least here align that they are both lists, for example. We could provide here a list of and get the array inside, or let's make code more readable and define a method. So we have a get methods. Similar way, we will define a list field, get fields from object. So let's start by retrieving a class. Then retrieve fields. And as we don't need any manipulations here, we just can wrap it into the list and return as is. Okay, so now here we can change it to get fields object. And we no longer need this class. And here we don't need array stream anymore because fields is no longer array. We just ask array field stream. Now we have ended up with two lists. One is field type, one is meta type. Sadly, they are not compatible to be handled together as single list of objects because they are different types. One has get for retrieving value, other one has invoke to call the function. But we would really want to handle them as a single because ideally they have both a name and have a value. So in order to combine them into a single list, we need to some common structure. For example, we could define our own key value pair that there is a name and the value and map them into this common structure to combine them into the single list. Before we do that, we can always check maybe there is already some sort of relationship between these classes. So for example, if you look at this small snippet of Java Reflection API, we can see we have a field that is extending an accessible object class. Accessible object allowed us to override these modifiers like with the function setAccessibleTrue. And field implements a member interface. If you look at the method or constructor, we can see that they extend the abstract class executable that has this invoke method that can be called to execute the function or constructor. But the executable implements a member and also extends accessible object. We see that we have already two common things that we could use. It's just a matter which abstraction is more needed for us. We are interested in two things right now. One is the retrieval of name and presence of annotation. If you look closely, there is no clear winner. Member interface has the name but does not have annotation information. Accessible object has the annotation information but does not have other things. I think let's, for learning purposes, work with the internal classes that we have. So we now need to combine them. So let's create a stream combining these both elements together. In Stream, there is a handy function that is called concat, where we can provide two streams and it will be combined them together. So fields stream and methods stream. Let's introduce, for example, local variable. So now we have a stream of members and we would like to repeat everything that we have here, but with this new stream. So first step is to filter out anything that has JSON ignore annotation. Currently we have them only on field level, but I think it also makes sense to add them to method level. So we could ignore some getters if you'd like, if user wants temporarily to disable some output. So let's add this filter and instead of field now refer to a member. So we can see it was actually smart enough to infer that the type is not just only a member, but also accessible object. So here we could access both things like getName and also is annotation present. But we are currently interested in ignoring this member. So now we need to update this shouldIgnore function. So instead of accepting field, it would accept, for example, accessible object because it already knows that this is either a member or accessible object. And we know that member doesn't have any annotation functions available, so accessible object would be the perfect candidate here. So accessible object is annotated with JSON ignore. Now returning back, we can see everything is ready because we have transformed our stream. Before that, it was a stream of members here, but now by filtering, we have confirmed that we are using also the accessible object part. So we need to here change type. And now it says something that extends accessible object. So now we have filtered the ignore part and it still knows that it's both accessible object and a member. Then here we could proceed with the mapping. So member here. So first step would be to extract a name. So get name, and again we have a member here. Now we need to change again the type from which we want to extract this name. Sadly, we cannot reproduce the same type inference here. We need to specify one of them. So let's stick to the member here. Instead of field, we will provide a member and rename this field also to a member. So changing it to member, we can see we have fixed that getName because member interface has the getName function, but it does not hold any information about the annotations. All the information about the annotations is held in the annotated element interface. And by default, member is not extending that interface, but we know that method and field both do. So other option would be here to put again accessible object or annotated element, and it would fix the annotation is present part, but it would not fix the getName because we are losing that. So As we would like to have both of them, we cannot. We need to stick to one and cast and check for the second one. So let's apply a type check with the pattern matching. So here, just before the member is annotation present, we could check if this member is instance of annotated element. So it means if this member implements this interface. And we actually, with pattern matching, can create a variable here and use this variable further in our checks and inside these if statements. So instead of member, we could use this annotated element, get annotation, and return value back. So now when we receive member, first we check if the member is annotated element. If it is, we assign it to a variable, cast it, and check if the annotation is present. If annotation is present, we extract it and provide the value. Now going back, we have fixed the name. Now we need to somehow get the value. And we have this as JSON value to either quote the values or not. And for the value itself, we had this get field value. Let's just declare method get value and provide a member and our object on which we want to read this value from. Let's find our get value. We can see it was like that. Now we would like to have it as object get value, provide a member, and object from which we want to read. Now here is a bit more trickier part. We know that it either could be a field or a method, and they both differ how we read the value. So for the values, it's quite simple. We have seen we need to set accessible true and retrieve it from object. But for methods, it's a bit different syntax because there is no value to read. We need to invoke a method to call, to execute some sort of code that is user defined. So, and for that, if we check the method class, we can see there is an invoke method that accepts an object on which we want to invoke this method, then the arguments that we need to provide, and it returns the result. So now again, we can leverage the pattern matching and use a switch statement and based on the type, execute either get or invoke method. So we just here return a switch and provide our member. And case it is a field, then we execute field get and provide our object. So you can see the pattern matching will test if this class is of this type. It will automatically cast it and we will execute these steps. There could be thrown exception. We know that we need to check for the private fields and override actually that setting to access the private fields. Let's put that around with try catch. Here we could fail with some exception. Let's do the back practice and do a generic catch with the reasoning that if something fails at this step, there is no reason to proceed. There is no a way that we can gracefully handle it. So I will just rethrow it as a runtime exception because it works better with streams. So now that we have it, now we need to have another case if it is a method. And for method, we know that instead of get, we can use invoke to call this function on this object, and we know that it's a getter. It should not expect any parameters, so we leave it all these values empty. So the only downside of this switch expression is that we need to provide a default case. If it's not a field or a method, there is a default scenario, and for it we will just throw some sort of exception that will be catched here. For example, unsupported member. It is so. In default case, we will throw exception unsupported member. In real world scenario, it should not be possible because we control what we provide here. But if we would have this function as more generic for everyone to use, then of course it could be problematic here. It looks good. Let's go back up and see that we have the name, we have the value. Now we need to return it with this format. I will just copy over and collect as concatenated. So now we can remove our old code and leave our new one. And instead of this variable, we will just set a return. So let's go over again. We extract fields, we extract methods, concatenate these streams together because they have common interface. In this case, it is accessible object and member. They are both accessible object and members. Then we check if this member should be ignored by having our accessible object passed here and we are checking for annotation present. Then we do the mapping, extract the name. It's either from the annotation or the member name. Then we retrieve a value based on the member type again. If it's a field, we retrieve it using get. If it's a method, with invoke, and collect the results together. So we can see we had two collections that didn't quite work together, and we have transformed our logic to handle it as a common interface type. It would be much easier if we would define our own intermediate class that we could use here, like some sort of pair. But it was a good practice to play around with the tooling that we have in Java. Now that we have implemented it, time to run the tests and see if we have broke anything. Let's rerun all the tests. And sadly, we have failed most of the tests. And if not for these tests, there is a big chance that we would miss some of these cases that we have actually broke them. So if we look at the tests, most of them are throwing illegal access exception. And from last time we know why it's happening, because we need to override the accessibility parameter in order to read these fields. And we have not included that in our new logic. Whereas the get value, we have not included it here. We could have an if statement that checks if this member is an accessible object. We actually know, thanks to this hints, that during this step, it's both member and accessible object. So for us, it makes more sense to have, instead of member here, an accessible object. Nothing changes in our output, nothing changes in our code, it's just the interface that we are referring to. It's still a valid pattern matching because there are common inheritance here. Now we can do some manipulations. For example, before returns of this statement, we can set this member as accessible. And we can add the finally statement where we put this flag back. While it's not required, it's a good practice so that we don't accidentally expose something more that we need. Okay, let's now rerun the tests and see the output. So indeed, we were able to combine two fields into one using a getter. So everything is green except one test, and this again showcases the power of TDD, because there was a really high chance that we would miss this case. Let's see what has failed there. And if we compare the output, so we expected to have JSON with two fields, title and views, but in reality we received title, views and views one more time. So for some reason this field was included 2 times. And the reason here is quite simple but might not be visible at glance. So records were introduced to reduce a boilerplate. We can specify fields and it will create such immutable data structure. If we check what's inside of the record, for example here input dot, we can see it has page views and title as fields as well as methods. Because we have defined them in a single place, like here string title and int page views, it copies over those annotations that are set on the field to the method, resulting in duplicate entries, one in the field and the second in the methods. That's why in result we have received 2 views as an output. The proper way how we would handle is to check for the duplicate entries. Of course there are different strategies, either we ignore duplicates if they are found, or we throw an error if duplicate is detected. The error case probably is not here applicable, as records, as we understood, will always create this duplicate. And actually this issue is more than just a record. We could specify a field and a getter that would have the same name. Nothing currently is stopping us from doing that. And again, while we are here, let's create a test for it so we do not forget that we had such bug. So given that we have some class book, not only records but classes, that has some field string author, for example, and it also has a method get author that returns author, but it has a JSON property name author. So here should be a collision, so it should output this field and also the JSON property from the getter. So let's create an input for it, new book, input author is John. When we call the mapper, then we expect to return only single field author with value John, and do the assertion. And for debugging, let's print the actual one. By running the test, we can confirm that this is not only with the records, this is a bug in our logic that we need to handle. Now let's think how we could solve. Ideally, we would like to ignore duplicate entries. So here we have concatenated fields and methods and we are processing them together in single stream, and we're trying to go one by one. But before we are doing these operations that we have here, we would like to get rid of the duplicates. So we can define here a unique members property, and it would be coming from same stream. Before we are doing any processing, we would like to go over all of these fields. Again, we can remove the ones that we should ignore. And now we would like to group them by the name. So for that purpose, we can use a different collector that is called, for example, to map. Quite simple. It accepts multiple parameters. First one is how we can get a key. So if we have a member, we need to extract a key for it, and for that we had this function getName. So this would be how we extract a key. For value, we could return the member itself, but we are more interested actually in the value that's inside this member. So we can do the mapping already at this moment. So we have a member, and we can run our logic as JSON value, get value from member of this object. We could technically add here a debug statement so we can see how it was collected. So let's rerun the test. And there is a failure, the duplicate key. So the author was multiple times and with the same values actually. So duplicates are not handled by default. To address it, to map collector has a merger option where it will tell which of the two values to use in case of conflict. So for example, if we have value A and value B, I'm just interested in one of them. Let it be A. Let's rerun the test. And we have fixed this duplicate key exception. And you can see the content of the map. It's just one field author and John. So our map indeed holds now unique members. So it means we don't need this part anymore. We can just say unique members entry set. We want to stream it. Then we want to map each entry using our format, and instead of name we will use the key value, and instead of value we will use the get value. Now we need to just collect the results with joining as previously. Let's rerun the test, and it's green. So let's go to all of the tests and see if we have fixed all of the cases. So we have executed all of the tests and see that still one test is failing. And it is really strange, we have not failed it before. And if you look, it's about the primitive fields. And if we look at the difference and go one by one, but we can see that the only difference here is the order. And we know because the map and sets doesn't preserve orders, we will get quite a random output depending on the element count. So in reality, we don't care about the JSON output order. So I can just update here expected. And for me, it will be fine if the order doesn't match how we have defined it in the class. Let's rerun the test, and everything is green. So now let's stop again here, and I would encourage you to go over the code again to try to understand each of the steps and decisions that we made. Played around with quite advanced language concepts like type inference. We saw how automatically we were able to determine that a member is both accessible object and a member, and it could be passed in one function as one and into another one as other. We played around with pattern matching and saw how casting and jumping from one implementation to another, given they are on the same hierarchy tree, it is quite easy now. We don't have to have this instance of and then casting. We could use either the switch expressions or the instance of and creating a variable in place. And join me for the last step of this JSON mapper, where we will handle nested objects and arrays. Afterwards, we will continue with annotation-based validation engine and ending with dependency injection. So if you like what you see, please share, leave a like. Your feedback and support is really appreciated here. Till next time.